And then we have also trend analysis that bring a broader or longer perspective. And then last but not least, we have the Baltic Sea Impact Index, which is the cumulative impact assessment of HELCOM. So the kind of main output of this work is the summary report that is summing up all the findings in the assessment. And then we have a range of thematic reports that cover certain topics. There's one for cumulative impacts, which gives the more detailed description of the results and methodology and such. There is also a separate website for this publication and the HELCOM Map and Data Service where you can find much more information. So about the assessment itself, as we know, the marine environments are facing multiple simultaneous and overlapping pressures. If we only look at them sectorally, one at a time, so we might be missing the cumulative burden all this pressure bring to the ecosystems. So that's the basic principle of the assessment on the right. So we have 18 pressure layers just representing the pressures occurring at sea, and then we have ecosystem components. And then we have sensitivity scores in the middle. So there's a sensitivity score, how sensitive each ecosystem is to each pressure. And then when we first multiply them and then sum them up, so we get the result. So I have a bigger picture here. So it is a 1 × 1 kilometer grid around the Baltic Sea showing the results. And the method is based on Halpern et al. That developed this in 2008. They made a worldwide assessment of cumulative impacts. And the method has been followed since. And it was first applied at HELCOM for HOLAS 1 back in 2010. So here is the sensitivity score matrix. So it's a really big table, almost 700 sensitivity scores. So it's been a really big task to compile all this information, and it's mainly built on results of expert survey and also literature review and such. And about the calculation, there are a few ways to calculate the actual index. Quite commonly is used a software called Eco Impact Mapper. We wanted to create our own tool, so we created an ArcGIS toolbox. We wanted to kind of keep it in our own hands and also to develop it further in the future, and it has been already developed. This is an old version actually of it. There's a newer one, and at the end of this month there's going to be actually an online version of this tool published. I will show it at the end of the presentation. Let's hope it works. It's going to be officially published at the end of the month, but there's a draft version now that we can have a look. And like I said, the formulas are based on Halpern, and you can see the formulas there. Maybe I will not go through them. So how this work was done, so mapping the pressures. So the foundation of this work was built on from several projects. So also already prior to the HOLAS 2 project. So we had the TAPOS project, SPICE and Baltic Boost project. They all contributed to this work and fed information to the HOLAS 2 project. And they had a lot of workshops, they did a lot of literature reviews and had a really lot of rounds of expert opinions to tackle the issue. So first you need to know what's out there. So what activities are present at the sea and what kind of pressures they might cause these activities. And all these activities and pressures are aligned with the Marine Strategy Framework Directive, Annex 3, which is listing kind of the official pressures and activities that are used in the directive, so they can be also used in that regard. And the next thing you need to think is how these activities are then transformed into pressure. So if we know we have certain activities, how do we make them into pressures? If you go into detail, you need to think about the matrices that you use calculating those pressures. So is it only occurring the pressure with activities, or do we use some kind of buffer? So how do we transform the activity to a pressure? And also the sensitivity score work. And in this project, they also did a lot of testing of approaches and methods to see how how they work. And this is one of the output from that work. So there is all the human activities listed on the left-hand side, and on the right we have the pressures, and you can see all the linkages they have in between. So it's a really complex system, and the pressures are grouped as they are in the marine MSFD, like input of substances, then there are input of energy, then we have biological and physical pressures. And about the dataset, there were altogether 39 dataset on human activities. They are collected by various means. The optimal solution is that there is a HELCOM annual reporting program that we can get the data directly from. If that is not possible, then there are a bunch of open sources where you can find information. We can make data requests to other organizations. And kind of the last option is to ask the countries where are these activities taking place. It's quite laborious for their countries, so that's why it's the kind of the last thing to do. Just to show you a few examples, we have data, for example, from bridges and other constructions, deposit of dredge material, wind turbines, cables, illegal oil discharges, shipping density, and fishing of herring, just to show a few. And about the pressures, so the pressure layers are giving information on the spatial distribution of these pressures on the scale of 0 to 1. Everything is scaled in the same way so they can be compared. And the reason they're called aggregated pressure layers is that some human activities affect the marine environment in similar ways. So in order not to overestimate their impact, they are compressed to form one layer. For example, the physical disturbance pressure layer. It's a combination of these human activities that are causing the same pressure. The same with physical loss. There are a lot of activities are causing this pressure, so they're all grouped to form one layer, and so forth. Another option is that we don't have the human activities, but we use directly the observations and modeling to create the pressure layers. So, for example, for nutrients, we have the information how much the concentration of nutrients in the sea. There's a quite good coverage on the observation points. So then we use means of interpolation to transform this into a pressure layer that looks like this. And another example is the continuous sound. So we kind of know what is the soundscape in the sea by creating these models. And then we were able to use expert opinions, what are the cutoff values, so where the pressure actually starts and what is kind of the maximal pressure. And then we can use those threshold values to produce the pressure layer. And about the ecosystem components, they are also giving information from 0 to 1. And there are altogether 36 of these layers. They are collected by similar kind of means. And there's a few different type of data. For example, for benthic habitats, we have presence absence data. So you either have it or you don't. For example, focus and large-scale habitats. Then we have also classified distributions. So we have, for example, for harbor porpoise, there are these classes for different kind of occurrence, and they are all assigned a value. So we get these classified values. And also some continuous data, like for the fish. So we have the abundance as a value from 0 to 1. And then one more example of the absence presence is birds. So you either have birds or you don't have birds. And just to give you an example of a chain from activity to pressure, this is for dredging. So first thing you do, you need to have the method how you assign this. So this was these projects and also the HELCOM expert network for dredge material was creating this. So it causes the pressure from dredging it causes physical loss when it's capital dredging. So when they dredge like pristine areas that hasn't been dredged before, and then it causes physical disturbance if it's maintenance dredging. So if it's an already dredged area that you maintain, for example, at a certain depth in fairways and such. And then the data part, so where to get information about this. So there was no regular reporting about this, neither any open sources. So there was a national data call to get this information from all the contracting parties with like the information on the where it is happening, about how big is the extent, and also how much is stretched, so the amount. So then you need to decide the actual matrices. For physical loss, it's rather simple. It's just also binary, so it's either lost or not, and the whole area is just considered as loss. And for disturbance, the extent and intensity was taken into account, so there was a certain kind of buffers, and also the intensity was based on the amount of dredged material. So there were certain kind of buffers and intensity consideration made, and these were made by the project and then the expert network. And then when you have the activity per pressure layers ready, then you need to aggregate them to form the final pressure layer. So for physical loss, it's as simple as it is this binary type of information, so it cannot be lost twice, so it's only either it's lost or not. For physical disturbance, it's a bit more complex, as we have the intensities, so we need to weight them according to the different kind of activities, and then you sum them all up, then you get this continuous information from 0 to 1. And I have an example here for physical disturbance around the archipelago sea. So this is the disturbance caused by dredging, and then you combine it with other layers, such as shipping and recreational boating, and all the other layers. Then after that, you sum them up, and then you get the final layer for physical disturbance. And then last, about the further development. So there are still a lot of things need to be developed. First of all, to fill these spatial and temporal data gaps. A lot of areas that we don't have that good information. And as we have a regional sea, so the data coverage and quality varies a lot between different countries. And there is still work on the linkages between pressures and ecosystem. And also considerations on the temporal resolution, as we have in this assessment, we have a fixed time period from 11 to 16. So we should ask the question, are we only assessing the pressure occurring at that time? Because some of the layers also include like historical sins in their data, so it's a bit mixture of temporal scale. And also the contracting bodies have different methods of defining some ecosystem components. They have different level of inventory programs. And the fact is that if you don't have information in some species, it results in low impact because there is nothing to be affected by the pressures. And the tool is going to be also further developed. It's already available in GitHub. So the source code for the tool can be found there, and it can be used in many desktop like ArcGIS desktop software. And then it's the online tool. I can show you a bit if I manage to make it work. So the tool looks like this. So this is an early version, and it's a bit hard to use. But we have a section for the layers. So here are the layers available for the calculations. So if it's too much to try to click, it's rather difficult. So it opens up there, and then we have the actual calculation part here. We can choose a set of ecosystems and also pressures. We'll try to select 2. And then when you press to get the sensitivity score, so it automatically pops up there. Okay, if you scroll down, it comes here. And they also, you can edit them on this page. And then you just press calculate. This should be rather fast. So the results pop up there, and if you have any open layers from the layers section, you can use this
also this swipe tool to compare how it affects the pressure layer and the water stream bank. So this is how it works. I hope it will look a bit better and function a bit better when it's officially published by the end of this month, but it's there for everyone to use. And I don't know how to get back to the presentation, but the last slide said thank you, so that was it.